Hello friends, in this lecture we will cover the next part of our communication system, that is electromagnetic spectrum, or it is also called as an IEEE frequency spectrum. Now the learning outcomes. Now after studying this topic, student will be able to understand first what is electromagnetic waves, then the electromagnetic spectrum, and the allotment of frequency bands for the different applications. Now before going to start our electromagnetic spectrum, let's see what is electromagnetic waves. Because to understand the concept of our electromagnetic spectrum, what is electromagnetic waves is very important. The information signal should be converted into electromagnetic signal before the transmission, because the wireless transmission takes place using the electromagnetic waves. In last lecture, we have covered the wireless communication media. In wireless communication media, we always transmit the information from transmitter to receiver in the form of electromagnetic waves by using the transmitting antenna and the receiving antenna. So the electromagnetic waves consist of the both the fields, that is electric as well as the magnetic field, and the electromagnetic waves can travel for the long distance through the space, and the electromagnetic signal are also called as an radio frequency signal or radio frequency waves, that is RF waves. And the frequency of electromagnetic waves can be very low or it can be extremely high. Now here this picture shows the electromagnetic waves. Now basically the electromagnetic waves is nothing but the combination of the both the fields, that is electric field as well as the magnetic field. Now if you observe the blue color waveform, that indicates the electric field, while the red color waveform indicates the magnetic field. And if you observe the waveform, then these electric fields and magnetic fields are always in right angle to each other, and this indicates the combination of the electric field and the magnetic field. Now let's see the electromagnetic spectrum. Now this is electromagnetic spectrum. Now electromagnetic spectrum, or it is also called as an IEEE frequency spectrum, and this why this spectrum is called as an IEEE frequency spectrum? Because this spectrum is invented by IEEE, that is Institute of Electrical and Electronics Engineers. And here there are various frequency ranges are available. Now the frequency will increase from ELF, that is extremely low frequency, to extremely high frequency, that is EHF, and the wavelength will decrease, because we know our frequency and wavelength are inversely proportional, wavelength which is in lambda. Now the first frequency, that is ELF, that is extremely low frequency, and the frequency range for the extremely low frequency is in between 30 hertz to 300 hertz, and the wavelength for the ELF is in between 10 raised to 6 meter to 10 raised to 7 meter. Now the next frequency, that is the voice frequency or VF, and the frequency range for the voice frequency is in between 300 hertz to 3 kilohertz, and the wavelength is in between 10 raised to 5 meter to 10 raised to 6 meter. Now the next frequency is VLF. VLF is nothing but very low frequency, and the frequency range for the very low frequency is in between 3 kilohertz to 30 kilohertz, and the wavelength is in between 10 raised to 4 meter to 10 raised to 5 meter. Then the next frequency is the low frequency or LF, and the frequency range for the low frequency is in between 30 kilohertz to 300 kilohertz, and the wavelength for the low frequency is in between 10 raised to 3 meter to 10 raised to 4 meter. The next frequency is the MF, that is medium frequency, and the frequency range for the medium frequency is in between 300 kHz to 3 MHz, and the wavelength for the medium frequency is in between 10 raised to 2 meter to 10 raised to 3 meter. Then the next frequency is the high frequency or HF, and the frequency range for the high frequency is in between 3 MHz to 30 MHz, and the wavelength is in between 10 meter to 10 raised to 2 meter. The next frequency is VHF, that is very high frequency, and the frequency range is in between 30 MHz to 300 MHz, and the wavelength is in between 1 meter to the 10 meter. Next frequency is the UHF, that is ultra high frequency, and the frequency range for the ultra high frequency is in between 300 MHz to 3 GHz, and the wavelength is in between 10 raised to minus 1 meter to 1 meter. Then the next frequency band, that is SHF. SHF is also called as an super high frequency, which have the frequency is in between 3 GHz to 30 GHz, and the wavelength is in between 10 raised to minus 2 meter to 10 raised to minus 1 meter. And the last frequency band, that is EHF, that is extremely high frequency, and the frequency for the extremely high frequency is in between 30 GHz to 300 GHz, and the wavelength is in between 10 raised to minus 3 meter to 10 raised to minus 2 meter. Now the next frequency band is for the millimeter waves, and the wavelength for the millimeter waves is in between 10 raised to minus 3 meter to 10 raised to minus 6 meter. Then the next frequency band is for the infrared. Then after the infrared, the next frequency band is for the visible light, and the last frequency band is for the high rays, that is X-rays or the gamma rays or the cosmic rays. Now this is all about the electromagnetic spectrum. Now if you observe the electromagnetic spectrum, then you will get idea. The frequency is goes on increasing while the wavelength is goes on decreasing, means our frequency and the wavelength are inversely proportional. Now let us see the allotment of frequency bands for the different applications. Now the first frequency band is the extremely low frequency, which have the frequency range is in between 30 Hz to 300 Hz, and this frequency range is used for the power transmission. Then the second frequency band, that is voice frequency, that is in between 300 Hz to 3 kHz, and this frequency band is used for the audio application. Then the third frequency band, that is very low frequency, which is in between 3 kHz to 30 kHz, and which is used for the submarine communication or the navy communication or the military communication. Then the fourth frequency band, that is low frequency or LF, which have the frequency range is in between 30 kHz to 300 kHz, and the frequency band which is in between 30 kHz to 300 kHz is used for the aeronautical and marine application or the navigation application. Then the next frequency band is the medium frequency, which is in between 300 kHz to 3 MHz, and it is generally used for the AM radio broadcasting, that is amplitude modulation radio broadcasting. Then the next frequency band is the high frequency, which lie between the 3 MHz to 30 MHz, and this is used for the short wave transmission. Then the next frequency band, that is seventh frequency band, that is very high frequency or VHF, which lie between 30 MHz to 300 MHz, and which is used for the TV broadcasting or the FM broadcasting. Then the next frequency band, that is ultra high frequency, which have the frequency range is in between 300 MHz to 3 GHz, and which is used for the ultra high frequency TV channels. Then the next frequency band is the super high frequency, which have the frequency range is in between 3 gigahertz to 30 gigahertz, and which is generally used for the satellite or the radar communication. Then the next frequency band is the extremely high frequency, which lie between 30 gigahertz to 300 gigahertz, and which is used for the satellite and the specialized radar communication. Then the next frequency band is for the infrared, which is in between 0.3 terahertz to 300 terahertz, and it is used for the electronic photography or the astronomy. And the last frequency band, which is for the visible light, which have the frequency range is in between 0.3 picohertz to 3 picohertz, and which is used for the fiber optic communication. So this is all about the allotment of frequency band for the different applications. Thank you.